my name is Jess Roach, and today I'm going to present to you the findings of my research reporting on the incidence and causes of pregnancy loss after day 70 of gestation in UK thoroughbreds. So funding for this work was provided by the Albarada Trust, and the only competing interest to declare is that Alistair Foote, one of the authors, is also a partner at Rossdale's and heads up Rossdale's laboratories. We'd like to acknowledge the stud farms who took part in this work and without whom this research wouldn't be possible, along with the clinicians at Rossdale's and NEH and Christine Gerd. So just an intro into why we carried out this work. It's evident through the review of the literature that there's a need for a standardised approach when quantifying and diagnosing pregnancy losses. Prior studies have reported on the case proportion of different diagnoses, but these only reflect findings on material that was submitted for postmortems at diagnostic laboratories. The data therefore might not reflect the actual incidence, as it does not take into account those cases that were not submitted to a lab for investigation or the absolute number of losses in the population. Studies reporting on the incidence of cause of loss at a population level would allow for a more accurate comparison of regional differences and in turn allow for exploration of risk factors, both for the different reproductive loss phenotypes, and the common causes primary diagnoses. This study therefore aimed to report the incidence and causes of pregnancy loss after day 70 of gestation in a large cohort of thoroughbreds. Additionally, the presentation of the loss and form of investigation will also be described. So methods, a retrospective cohort study collected data from 8 thoroughbred stud farms over 5 breeding seasons from 2013 to 2017. Stud records were supplemented with veterinary practice records, diagnostic laboratory reports, and Weatherby's return of mare data. Day 70 of gestation was chosen in order to exclude losses diagnosed at the day 65 scans, which were likely a result of pathologies established during the early pregnancy period. Following outcomes were recorded either as a live foal at 24 hours post-parturition, pregnancy loss diagnosed up to day 300 of gestation, pregnancy loss diagnosed between day 300 and 315 of gestation, and stillborn/perinatal death, which was defined as a loss diagnosed between day 316 of gestation and 24 hours post-parturition. A custom criteria was developed using pathological features identified in peer-reviewed publications of the different causes of pregnancy loss. This was then applied to the primary diagnosis and the pathologist written report, post-mortem report, to categorize and standardize the diagnoses. One author categorized the diagnosis of all the post-mortem investigated losses, and to validate the approach, a second author blinded to the assigned categories graded as subset. Of the 35 categories were then grouped into umbilical cord-related pathologies, infectious placentitis, which did not include equine herpes virus infections, non-infectious placental diseases, pathologies of fetal origin, and no primary diagnoses. So moving on to the results, and just a note here to say that since the abstract was submitted, I've actually collected additional data, therefore some of the figures will differ, but the overall findings are the same. So data was collected on 3,586 pregnancies from 1,802 mares over 5 breeding seasons. Data was not available for the 2013 and 2014 season for one of the farms. Mares were covered by a total of 132 stallions located in the UK and Ireland, and a foaling outcome was available for 3,516 pregnancies, while 70 were lost for follow-up, primarily through sale or export, representing a 2% dropout. The median mare age was 8 and the median stallion age was 11 years old. Of the 3,500 pregnancies, 2/3 of them were from foaling mares, and the other third was split almost 50-50 between maiden mares and barren or rested mares. The farm were a mix of commercial and private operations, with the median number of mares per farm being 79. So moving on, this is figure 1, and it shows the incidence of pregnancy loss after day 70 of gestation in the bars and on the left axis, and then the incidence of live foal on the right axis. The first column shows the total over the 5 years, and then they're stratified by year of cover, and the bars represent the 95% confidence intervals. So shown in orange and on the right axis, you can see that the proportion of day 70 pregnancies which went on to produce a live foal at 24 hours post-parturition was relatively constant over the 5 years and stood at around 93%. Pregnancy failures diagnosed prior to 300 days, often termed abortions, were the biggest contributor to pregnancy loss in this population, followed next by those diagnosed after day 315. Although in this group it was not possible to differentiate between stillbirths and perinatal deaths. There was no yearly variation shown by the overlapping confidence intervals. So here we've managed to quantify when in gestation these losses are being diagnosed, but next I wanted to know what investigations were taking place and ultimately how much of the population is being captured in the lab-based studies. So here is figure 2 showing the instance of investigation, and remember that this is at a population level, so of all the day 70 pregnancies. These are then grouped on the x-axis into time and gestation that the loss was diagnosed. As you can see, in all of the time categories, full post-mortem examination was the most frequent form of investigation and accounted for almost 60% of the losses pre-day 300, or 86% of the losses where aborted material was available. For the losses prior to 300 days, when no aborted material was available, these were primarily mares which were palpated as not in foal in the October checks. Interestingly, of the losses occurring after day 315 day of gestation, only 50% of these underwent post-mortem examination. This means that we may actually be underestimating the cause of loss occurring in this late stage in gestation / the early perinatal period, both in this work and in previous laboratory studies. Encouragingly, when aborted material was available, almost 90% was screened for EHV, be it either through full post-mortem or just a PCR screen. So in the second part of this study, I wanted to quantify the incidence and risk of the cause of pregnancy loss in this population. So across the 5 years of the study, the total incidence of pregnancy loss due to umbilical cord related pathologies was 1.5%, shown in blue here. Then infectious placentitis was 0.3%, shown in purple. Non-infectious placental disease was 0.4%, shown in mauve. EHV was 0.3%, shown in pink, and fetal pathologies was 0.2% and shown in orange. Whilst there is seasonal variation in the instances, the confidence intervals again overlap, suggesting no significant variation. There is a clear spike in EHV cases in 2015 coverings, reflecting the storm nature of these cases. Umbilical cord related pathologies were the most commonly diagnosed cause of pregnancy loss, accounting for almost half of the post-mortem cases. 98% of these umbilical cord related pathologies were umbilical cord torsion or suspected umbilical cord torsion, and the final 2% were long cord with ischemic necrosis. So this is the first time the incidence risk of these causes of loss have been presented in a cohort study, and clearly shows that umbilical cord related pathologies are the biggest diagnosed contributor to pregnancy loss after day 70 of gestation, and has an incidence risk of 1.5% in this population. So the main limitations of this study were that it was not possible to reliably differentiate between intrapartum stillbirth and early postpartum death using the retrospective data, meaning that these phenotypes had to be grouped. It'd be really interesting to separate out these phenotypes to ascertain those fetuses that died during parturition and those that delivered a live foal but whom died within the first 24 hours of life. Secondly, it must be recognised that the farms in this study were all intensively managed medium to large thoroughbred farms, therefore the instances might not reflect the small breeding operations or different breeds. For example, there are recognised differences in amniotic cord lengths between breeds, so whilst it isn't clear, this could result in potential breed predispositions for umbilical cord abortions. Finally, the instance of cause of loss in this study are based on the diagnosis being attributed. Therefore, the reported values are likely underestimates for the true population instance. However, we believe that the data reporting the proportion of cases submitted for investigation provides an understanding of the limits of our findings. So in conclusion, this study presented a standardized approach for quantifying and diagnosing pregnancy losses, which can be applied to different populations. This data therefore provides an important benchmark for global and temporal comparisons. The incidence of pregnancy loss after day 70 of gestation has not changed in the last 15 years. The incidence risk for umbilical cord related pathologies was 1.5% of all of the day 70 pregnancies, and was the most common diagnosed cause of pregnancy loss. This supports the case proportion data from previous lab-based studies and was almost 4 times that of the next most commonly diagnosed cause of pregnancy loss. Post-mortem diagnosed infectious placentitis resulting in abortion occurred infrequently in this population. There were no cases identified of novel causes of abortion that have been identified outside the UK in recent years, such as chlamydia or any syndrome similar to mare reproductive loss syndrome. So the data from this study provides an important benchmark which can be used to monitor the success of interventions to reduce the risk of causes of abortion, such as umbilical cord torsion or placentitis, and also to monitor trends in reproductive efficiency over time. Thank you for listening, and I'd welcome any questions to this work.